Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. For happy engineer, wherever you are. Now I would like to share about one of structures analysis methods. In this moment, I would like to introduce Takabia method for multi-story frame structures analysis. This video is one of my lecturing video series that talk about Takabeya methods. If this channel was helpful for your study, don't forget to subscribe and press the notification bells. Enjoy this. Let's say we have a beam with the concentrated load that was applied on, and we have an elastic deformation curve of the bending deformations that was caused by loading. So we have slope at the bottom of each of the beam E and B, or next we call them theta E and theta B. That was indicated the tangential of the elastic deformations at the edge of the beam E and B. Then we have moment EB or BE, both of each of the beam. Hence, we can derive the fundamental equations. Moment E and B is equal negative fixed ending moment EB plus delta the moment rotations at EB. Conversely, the moment BE is equal positive fixed ending moment BE plus delta the moment rotations BE. Similarly, with the slope depiction formula, the Takabia method used the moment rotations that replace the slope at the slope depictions in its formula. For examples, for evaluating or counting the bending moment at EB section, we can determine it by multiplying the stiffness of the sections AB and two moment rotations at node A plus the moment rotation at nodes B plus the moment rotations bars and sections EB, then mean minus fixed ending moment AB. Minus or plus in the of a fixed ending moment, it was depend on sign conventions that you use. Okay, so clear that the moment rotation is equal the modulus elasticitas, stiffness of member, and the slope itself. In another hand, the moment bars SB was related into the modulus of elasticitas E of the material, of course, and the stiffness of a section or a member, and a delta or a displacement in the sections AB. Based on the fundamental equations, we have a theory of virtual work, Castigliano's theorem, differential equation of elastic line, Moore's moment area theorem, Kani and Takabia methods for structures analysis. Of course, they use the parameters correspondingly, the stiffness of the member, the modulus of elasticitas, the moment of inertia, slope and deflections, the moment of rotations, and the moment distribution itself. For example, we have unsymmetrical frame structures with two bases and two floors. Of course, it has unsymmetrical loading too that were carried on the beam of the frame structure systems. Okay, the member stiffness, even for beam stiffness or column stiffness, had been shown in the pictures. Okay. This is really different between these problems or these examples and the previously examples in another hours video tutorial of Takabia methods, because in this problem you should to evaluate or to calculate the bending moment at every node that were available in this frame structure system because of the unsymmetrical reactions. The first step in Takabia method, you should prepare all parameters that were involved in the moment rotations determinations at every node, of course. There are the row variants in every node, the calculations of tau and every node too, the effect of the height of stories, T, the gamma at every sections, and the moment rotations itself. Now we're gonna look to row variant at node E. What is the row variant? Of course, the row variant is the summarizations of the stiffness member that were connected in one nodes that you consider, or the nodes where you count the bending moments that was occur. Then you multiply it by 2. Okay. And how about tau? Tau was related into the fixed ending moment, and of course the negative or positives, it really had a significant effect about your calculations here. Next, we would like to evaluate the moment rotations at the first iterations, or M0, that you can find it by dividing tau and row variant in the same nodes. The effect of the height story should be considered as T parameters that involved the column stiffness and divided into total column stiffness. Okay, so we get T at the column 2B and 2-1E and 2-3C for the first floor and the second floor. The gamma parameters can be found by dividing the stiffness member with row variance at the nodes required. So here we can find every gamma at every sections of the member that were found in the frame system structure. The final step of calculation procedures in Takabia method is how to calculate the moment rotations bar for the first or the second story. The moment rotation bar had been evaluated by consider the head story effects, or we called it T parameters. Then by utilizing the moment rotation bar, we can calculate every moment rotation at the first moment rotations iterations calculations in every nodes E, B, C, D, and so on. The simple way you can do in this method, you can write down your all calculation iterations in every node of the frame structure systems. But you should identify and assign all parameters, such as gamma, row variance, furthermore T, even more moment rotation itself in every nodes and every sections correctly. The calculations of design moment can be conducted by utilizing the moment rotation and the moment bar rotations in the last iterations course. So, by using the previous formulations in Takabia methods, you can find every bending moment in every sections. Yeah. In case nodes A, we have section ED, sections EB, and sections E1s. We have respectively the moments 1.24 ton meters for MED for section ED and negative or minus 2.24 ton meters for sections EB, and last 0.92 ton meters for sections or column E1. Of course, we have a theory here that the total moment or the total bending moment that will occur in these nodes, in this case nodes A, is 0. Okay? By utilizing the moment rotation at the fourth iterations, we have not 0 but minus 0.08 ton meters. Now we have an error minus 0.08 ton meters, and we're gonna use this for calculating the moment distributions for every sections, ED or sections EB and sections E1. Okay, by multiplying the error and the stiffness relatives, we can find every sections the corrected moment designs respectively for sections ED 0.025 tons meters and for sections EB 0.025 ton meters, and last for column E1s 0.03 ton meters. Finally, you can find the moment design corrected correspondingly 1.27 ton meter for bending moment at ED sections and minus 2.22 ton meters for bending moment at EB sections, and the last 0.95 ton meters for bending moment at column E1. For understanding the subjects better, you can read or practice with these references below. There are the Takabia multi-story frames by Professor Takabeya and intermediate structure analysis by Professor Wang. You can find these books in so many libraries surrounds you. Finally, thank you very much for supporting Unmetal Project channel in our services, structure analysis tutorial, finite element method tutorial, research partnerships, training and development, paper thesis, dissertation design, analysis, and forensic engineering project assistance. So don't forget, subscribe this channel, like, share, and comment, and turn on your notifications bell. Keep healthy, keep fighting, keep optimistic, and always do everything that can make your parents proud to you engineers. Have a nice day everybody. Assalamualaikum warahmatullahi wabarakatuh.